Hello everyone, and welcome to a little pre-lab where we are going to discuss looking at a very special kind of collision called an explosion. Now before you get all that excited, the things are going to explode using those little spring-loaded plungers on the end of the carts, if you remember the last couple of labs that we've done. So we're going to use those to create the explosion here. We're not going to get all chemical. So basically, here's the situation we're going to have. We're going to have two motion detectors, one on either end. Each motion detector will measure the motion of one of the two carts. And when you hit the little button on top, the plunger will go off and explode the carts. And so the question we are going to try to answer is, how do the momenta of the carts compare after the collision? How much is the momentum of one cart compared to the momentum of the other cart? So there's the purpose: to create graphical and mathematical representations of the relationship between the momenta of the two carts after an explosion. And just to see if what differences we have here, you can set those plungers to like 3 different strengths. So you'll want to do some trials with it kind of weak, and some in the middle, and some where you push it all the way in and you get the biggest explosion. You also can change the masses of the cart to see what effect that has, if any at all. So those are the things you're going to change, and kind of like the last lab we did, you're going to do a bunch of different trials, graph the momentum of one cart versus the momentum of the other cart, and see what you get as a slope to see if they are related, and if so, how. Now, in terms of what the equipment's going to look like, you're going to open up a file. The file will give you data that looks something like this. Now, this is basically the carts before you hit the little plunger. So nothing's moving, so the velocities are 0. Notice this is a big graph of velocity versus time. Right? One cart is represented by a blue line, one cart is represented by the red line. Now here's where the explosion takes place, and then here's the cart afterwards. Now you may wonder, why does it keep doing this? Well, as you'll see in the equipment, there's rubber bands on the ends, so the carts will bounce off the ends and then hit one another, and then bounce off the ends and then hit one another. So this is repeated collisions. Notice that each time the velocities get smaller and smaller because you are dissipating more and more energy. Just to throw in a little energy analysis there. So basically, this is the momenta before the collision, 0. The momentum after the collision can be calculated using mass times velocity. So if we take the little examine thing here, move it up to just after the collision, that's the velocity of the blue cart. Now, to get this one to move, you have to click up here. See, now it's going to move the red one, and that's this one, and you can move it down there. Notice they kind of stay linked together, so you kind of have to find a dot that's going to work for both of them, and then you can read the numbers off of here. So the red cart was going at about negative 0.91 meters per second. The blue cart was going at positive 0.90 meters per second. They're going in opposite directions. So again, you have to play with this a little bit over here to move these two, and that's all you really have to read. You don't really need all of these over here that happen afterwards, all the little extra collisions. We're really just analyzing one of them to see what's going to happen. So, hope you enjoy and have fun with this little experiment on explosions. Please be nice to the carts. Thank you.